Students, in the 8th standard, we were introduced to parallel lines. Today, let's review that concept. Observe these lines L and M. You will notice that they do not intersect each other. These are called parallel lines. Lines that lie in the same plane but do not intersect each other are called parallel lines. The statement lines L and M are parallel is written as line L parallel to line M. Now observe this figure. Line T intersects line L at point P and line M at point Q. P and Q are two distinct points. The line T is called the transversal of the parallel lines L and M. Remember, if a line intersects two given lines at two distinct points, then that line is called the transversal of those two lines. Due to the transversal T, a total of 8 angles are formed. 4 angles at point P and 4 angles at point Q. As shown in the figure, these angles are labeled as A, B, C, D, E, F, G and H. Each of these angles have one arm on the transversal and the other arm on one of the parallel lines. Among these 8 angles, there are certain special pairs of angles. Let's recall them now. Corresponding angles. A pair of angles where the arms on the transversal are in the same direction and the other arms are on the same side of the transversal is called a pair of corresponding angles. Each pair of corresponding angles formed by two parallel lines and their transversal is of equal measure. Let's identify the corresponding angle pairs in this figure. Angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. Angle D is congruent to angle H. Now, let's learn about interior angles. A pair of angles which are on the same side of the transversal and are inside the given lines is called a pair of interior angles. In this figure, the pairs of the interior angles are angle D and angle E, angle C and angle F. Also, we have the equations angle D plus angle E equal to 180 degree and angle C plus angle F is equal to 180 degree. Now let's learn about alternate angles. Alternate angles. A pair of angles that are on opposite sides of the transversal and have their arms on the transversal pointing in opposite directions are called alternate angles. Also, each pair of alternate angles formed by two parallel lines and their transversal is of equal measure. Now, in the given figure, angle D is congruent to angle F and angle C is congruent to angle E. These are the pairs of interior alternate angles, that is, angles at the inner side of the parallel lines. Angle A is congruent to angle G and angle B is congruent to angle H, and these are pairs of exterior alternate angles, that is, angles at the outer side of the parallel lines. Now let's prove these properties. We will first study the theorem on interior angles and its proof. Theorem on interior angles. When two parallel lines are intersected by a transversal, the interior angles on the same side of the transversal are supplementary. Given, line L1 is parallel to line L2. Line T is the transversal. Angle A, angle B, angle C and angle D are interior angles. To prove angle A plus angle D equal to 180 degree and angle B plus angle C equal to 180 degree. Proof. There are three possibilities for the sum angle A plus angle D. First, the sum angle A plus angle D is less than 180 degree. Second, the sum angle A plus angle D is greater than 180 degree. And third, the sum angle A plus angle D is equal to 180 degree. Let's assume that the first possibility, that is the sum of angle A plus angle D is less than 180 degree is true. Therefore, according to the Euclid's postulate, line L1 and line L2 will intersect each other when extended on the side of the transversal where angle A and angle D are formed. However, L1 and L2 are parallel lines, so they can never intersect each other. Thus, the sum angle A plus angle D is less than 180 degree is impossible. This is statement 1. Now, let's assume that the second possibility, that is the sum angle A plus angle D is greater than 180 degree is true. Therefore, the sum angle A plus angle D is greater than 180 degree. Now also we know that angle A plus angle B is equal to 180 degree because it is a linear pair of angles. Angle C plus angle D equal to 180 degree because it is a linear pair of angles. Let's add both these equations, then we get angle A plus angle B plus angle C plus angle D equal to 180 degree plus 180 degree equal to 360 degree. Let's rearrange the equation. After rearranging the equation, we get angle B plus angle C equal to 360 degree minus angle A plus angle D. If the sum angle A plus angle D is greater than 180 degree, then 360 degree minus angle A plus angle D is less than 180 degree. Therefore, the sum angle B plus angle C would be less than 180 degree. Therefore, according to Euclid's postulate, lines L1 and L2 will intersect each other when extended on the side of the transversal where angle B and angle C are formed. However, lines L1 and L2 are parallel lines according to the given information. Therefore, the sum angle B plus angle C is less than 180 degree is impossible. Therefore, the sum of angle A plus angle D is greater than 180 degree is also impossible, statement 2. Therefore, from statements 1 and 2, the only possibility left is the sum angle A plus angle D is equal to 180 degree. Now, in this proof, both assumptions, the sum angle A plus angle D is less than 180 degree and the sum angle A plus angle D is greater than 180 degree have proved false because both have led to contradictions. Therefore, we have concluded that the possibility the sum angle A plus angle D is equal to 180 degree is true. Since we have arrived at this conclusion by eliminating false assumptions, this is known as the indirect proof. Now, based on this theorem, we will prove the theorem of corresponding angles and the theorem of alternate angles. Theorem of corresponding angles. When two parallel lines are intersected by a transversal, the corresponding angles formed are of equal measure. Given line L1 is parallel to line L2. Line T is the transversal. To prove, angle X is equal to angle Y. Proof, angle X plus angle Z equal to 180 degree, equation 1, because it is a linear pair of angles. Angle Z plus angle Y equal to 180 degree, equation 2, according to the interior angles property of parallel lines. Therefore, angle X plus angle Z is equal to angle Z plus angle Y from equations 1 and 2. Therefore, angle X is equal to angle Y. Similarly, we can prove that the other three pairs of corresponding angles are of equal measure. Theorem of alternate angles. When two parallel lines are intersected by a transversal, the alternate angles formed are of equal measure. Given, line L1 is parallel to line L2. Line T is the transversal. To prove, angle W is equal to angle Y. Proof: angle W plus angle Z is equal to 180 degree, equation 1, because it is a linear pair of angles. Angle Z plus angle Y is equal to 180 degree, equation 2, according to the property of interior angles of parallel lines. Therefore, from equations 1 and 2 we get angle W plus angle Z is equal to angle Z plus angle Y. Therefore, angle W is equal to angle Y. Similarly, we can prove that the remaining pair of alternate angles is of equal measure. We have studied the properties of parallel lines and their proofs. Now, let's solve some examples based on these theorems. Observe this figure. In the given figure, line L is parallel to line M and line P is parallel to line Q. Observe this figure and find the values of angle A, angle B, angle C, angle D and angle E. Solution: angle A measures 70 degree, equation 1, because line P is parallel to line Q. Therefore, angle A and the angle of measure 70 degree form a pair of corresponding angles. Angle A plus angle B equal to 180 degree because it is a linear pair of angles. Therefore, 70 degree plus measure of angle B equal to 180 degree. Therefore, angle B equal to 110 degree, equation 2. Now line L is parallel to line M. Therefore, we have angle B congruent to angle C because they form a pair of alternate angles. Therefore, angle C equal to angle B equal to 110 degree, equation 3. Angle C plus angle D equal to 180 degree because it's a linear pair of angles. Therefore, 110 degree plus measure of angle D equal to 180 degree. Therefore, measure of angle D equal to 180 degree minus 110 degree. Therefore, angle D measures 70 degree, equation 4. Now, line P is parallel to line Q. Therefore, angle D is congruent to angle E because they are corresponding angles. Therefore, measure of angle E is equal to measure of angle D equal to 70 degree. Therefore, measure of angle E equal to 70 degree, equation 5. Now, in this given figure, line AB is parallel to line CD. Observe the figure and find the values of measures of angle QPR, angle PQR and angle PRQ. Solution: given, line AB is parallel to line CD and PR is the transversal. Therefore, we get angle BPR congruent to angle PRQ because they form a pair of alternate angles. Therefore, measure of angle PRQ congruent to measure of angle BPR. Therefore, measure of angle PRQ equal to 50 degree, equation 1. PQ is also a transversal, so we apply the property of interior angles. Measure angle APQ plus measure angle PQC equal to 180 degree because property of interior angles. Therefore, measure of angle APQ plus 120 degree equal to 180 degree. Therefore, measure angle APQ equal to 60 degree, equation 2. Angle APQ is congruent to angle PQR because they form a pair of alternate angles. Therefore, measure of angle PQR equal to measure of angle APQ. Therefore, measure of angle PQR equal to 60 degree, equation 3. Now, in triangle PQR, measure angle QPR plus measure angle PQR plus measure angle PRQ equal to 180 degree because the sum of all three interior angles of a triangle is 180 degree. Therefore, major angle QPR plus 60 degree plus 50 degree is equal to 180 degree from equations 1 and 3. Therefore, major angle QPR plus 110 degree is equal to 180 degree. Therefore, major angle QPR is equal to 70 degree, equation 4. Thus, measure of angle QPR equal to 70 degree, measure angle PQR 60 degree and measure angle PRQ equal to 50 degree. What did we learn? Parallel lines. Lines that lie in the same plane but never intersect are called parallel lines. When a transversal intersects parallel lines, each pair of corresponding angles is congruent. Interior angle theorem. When a transversal intersects parallel lines, the sum of each pair of interior angles is 180 degree. Each pair of alternate exterior angles are equal in measure when the lines are parallel. Exercise. In the given figure, AB is parallel to DC, and given that angle ABC 60 degree, angle ACE 105 degree. Find the values of angle BAC, angle ACD, angle DCE. In the given figure, AB is parallel to DC. The given values are angle ADC equal to 72 degree. Find the values of angle DAB, angle BCD. In the given figure, PQ is parallel to RS and AB is the transversal where A is between P and Q and B is between R and S. Now, angle BAQ is equal to 2x plus 3 degree and angle ABS is equal to x minus 15 degrees. Find the values of angle BAQ and angle ABS.